So we're going to do a little video here on the equal values method, and this is kind of a nickname for learning how to find where two lines on a graph are going to cross each other. So our example that we're going to use is we're going to have these two lines. I'm going to make them up here. How about y equals x minus 3, and y equals, how about negative 2x plus 6. And what we want to do is we want to be able to figure out where on the graph will the point of intersection between these two lines be. So obviously the best way to get an answer for a point of intersection is just to graph it. So we'll graph the first line at x minus 3. That means we're going to start down here at negative 3, and we're going to be going up from that point, up from negative 3. So if I was going to graph this, I would put my starting point here at negative 3, and it's a 1x if you really want to think about it. So it's a slope of 1, a growth of 1. So we go up 1 over 1, up 1 over 1, up 1 over 1. And we end up making this line that's going to cross through all of these points, and it's going to look something in the neighborhood of this. Like, we'll try and make it as best we can here. I wish I could add some arrows to the end of this. Maybe I need to draw some arrows on here, because the line's just going to keep on going. And then the other line that we're dealing with and looking at is the negative 2x plus 6 line. So that's the one that's all the way up here. 1, 2, 3, 4, 5, 6. Way up here at 6, it's going to be my starting point. So like right here is my first point. And it's got a growth of negative 2. So we're going to be going down 2, down 2, down 2. So down 2 and over 1 this direction. Down 2 and over 1. Down 2 and over 1, and I see a point of intersection here, down 2 and over 1. So I can easily see now what this line is going to look like. It's going to be something going kind of like this direction. So we'll be working with that. So I'll draw some arrows on here. And you can tell, like, after just a couple of seconds that, okay, well, now I know where my point of intersection is. It's right here. And so on the graph, that looks like it's at 1, 2, 3 over. So we have an intersection at 3, comma, in this case 0. Just happens to be where it crosses. And my answer to this point of intersection is 3 and 0. And I'm all set. Well, what if you don't want to solve by graphing? What if all this graphing work, after a while, becomes too much, or you just kind of get tired of it? Or what if the graph intersected, instead of at 3, 0, out at like 255? Some giant number. So what we're going to do is come up with a second strategy. So I'm going to clear this off. What if I took those two rules, so remember it was y equals x minus 3, and the other rule was y equals negative 2x plus 6. I'm going to write them back on the screen here. Now what I'm going to do is I'm going to take these rules, and instead of graphing them to find the point of intersection, I want to know where they cross each other, where they're equal to each other. So I'm going to take the rules, x minus 3, set it equal to negative 2x plus 6, and now all I'm going to do is what I know how to do really well, and that is solve for x. So I'm going to take this thing, I'm going to put a line down the middle of the equal sign here for a moment, and let's just go through the steps of solving this equation. The steps that we already know how to do from algebra. For instance, I'm going to add the 3 over here, move it to the other side. So I have x equals negative 2x plus 6 plus 3. 6 and 3 combined to 9. And then I'm going to add the 2x, flip it over to the other side, so it's a positive 2x on this side. And x plus 2x is 3x's. So I have 3x equals, this is gone. Now I just have a 9. Oh, sorry, that's a really big 9. But 3x equals 9. And so now all I got to do is divide by 3, and I get my answer. X equals 9 divided by 3 is 3. So my answer is x equals 3. So this graph must cross at x equals 3. Well, that's totally what we got when we drew the picture of the graph just a second ago. To finish this problem out, there's one more thing I can do, and that one more thing is I can solve for the y value. So I'm going to go over here and write solve for y. And solving for y means I want to get the point of intersection, both the x and y coordinate. So it's really easy to solve for y. You get a choice. You can either use this first equation up here, or this second equation. It totally doesn't matter. I'm going to pick the first one because it's such an easy equation that it won't take a lot of work. So I'm going to write y equals x minus 3. And I'm going to circle this x. I already think I have an answer for x. Remember, it's over here. I think x is equal to 3. So underneath, let's change that to a 3 instead of an x. So it's y equals, instead of x minus 3, it's 3 minus 3. And 3 minus 3 is 0. So I get this answer, y is equal to 0. Which means, final answer to this whole problem is, where does these two lines cross? Well, at 3 and at 0. So 3, 0 on the graph is the point of intersection. And that is the equal values method. So every problem where you're trying to find where these two lines cross, you have two strategies. You can draw the graph or do it algebraically like this. Kind of looks like a lot on this page, but it's often faster. And so if it's faster, it's a little bit easier. It's a good method. Alright, I hope that helps.